Hi guys, this is Zhijia Che. I'm doing homework 6, question number 2. So the question gives us that fx of x is e to negative x times the unit step function of x, and fyy is e to negative y times the unit step function of y. And the graph looks like this. So when the horizontal axis is x, this graph is fx of x. And when the horizontal axis is y, the graph is fy of y. So the question is to find PDF of the following random variables. So part A, we need to find fz of z when x when z is x plus y. So we know from last week's lecture, and we know that fc of z is the convolution is fx of z convolved with fy of z, and it's the integral of e to negative x times the unit step function of x times e to the negative z minus x times u of z minus x dx. And we can, here the integral is from negative infinity to infinity, but in this case we only have z that is larger than 0, so we take the integral from 0 to z, and we just rewrite this function as this, because now we take the unit step function out, and when x is z, the unit step function is 1 because at 0, because z minus z is just 0. So this is 1. Ux becomes uz. We write it here, and this integral becomes e to negative z times x from 0 to z times the unit step function of z. And when we plug in x as z, it's just z. So we have z times e to negative z times the unit step function of z. Okay, so for part B, we need to find f of z when z is equal to x minus y. Now we let w as negative y, and we do fw of w equals fy of y over g, the absolute value of g prime of y, and we get fy of negative w. So we have, so now we know when before we had this positive y, and we have the f of x of z convolved with fy of z, and now since it's negative y, and we did this procedure here, and we can get that fz of z is fx of z convolved with fy of negative z. Now the integral becomes from negative infinity to infinity. We have e to the x times the unit step function of negative x times e to the negative z minus x times the unit step function of z minus x dx. And since the unit step function here, the unit step function of negative x, we can write this as 1 minus the unit step function of x. So we rewrite this here, and the other things are the same. And the next step, we just we just take the parentheses out and we can have the first, the whole integral times 1 minus u, the unit step function of x, times the whole integral. So we have it here, the integral from negative infinity to infinity, e to the x times e to the, when this is 1, times e to the negative z minus x times the unit step function dx minus the integral of e to the x times, now it's the unit step function of ux times e to the negative z minus x times the unit step function of z minus x dx. And then since we have we just do the multiplication of the exponential function, and we get e to the negative z is just a constant, so we take it out of the integral, and we can have e to the x times e to the x. So we have e to the negative e to the 2x here. This is just simple calculations. And we go to the next step. We know that this part is from negative infinity to z, and this part, the integral, we take it from 0 to z. And now we just calculate the integral, and we have the 1/2 is come from the exponential e to the 2x, and we have half times e to the 2x from negative infinity to z times the constant e to the negative z, and we minus half of e to the 2x from 0 to z times the constant, times the constant u of z times e to the negative z. And then we just multiply this back here. I kind of just rewrite this here, and then yeah, I took out half of e to the negative z and times e to the 2z minus the multiplication of e to the 2z minus 1 times excuse me, times the unit step function of z. So, and this is half of e to the z when z is smaller than 0, and when z is larger than 0, we know it's half of e to the negative z. And so we write this as half of e to the negative absolute value of z.